Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we journey to Mercury, the innermost planet, to witness the longest and strangest sunset in the solar system. We'll stand on ancient cratered terrain as the oversized sun descends impossibly slowly. Watch it perform its peculiar backward dance, then embrace the instant darkness of an 88 Earth Day night. So settle into your most comfortable position, close your eyes, and prepare to experience patience on a planetary scale. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. Your breath carries you beyond Earth, beyond time measured in hours and minutes, into Mercury's realm, where days last 88 Earth rotations. Let each breath slow a little more. You are preparing to watch a sunset that takes not minutes, but Earth days to complete. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls naturally, effortlessly, matching the rhythm of cosmic patience we'll experience tonight. Let my voice be your guide. Hold this peaceful moment. Feel the stress of the day leaving your body with each exhalation. With each breath, you release a little more into relaxation, sinking deeper into comfort, preparing to observe the universe at Mercury's languid pace. One more breath. Perfect. We are ready to begin. Imagine yourself standing on Mercury's surface in late afternoon. You're protected, suited, comfortable despite the environment outside. Beneath your feet stretches dark gray regolith, ancient soil never touched by water or wind, unchanged for billions of years. The landscape around you is heavily cratered, each impact scar recording cosmic collisions from the solar system's violent youth. Above, the sky is pure black despite the sun still shining. Mercury has no atmosphere, no air to scatter light into blue or color. Just black sky filled with stars even now in afternoon sunlight. And dominating the western sky, the sun appears 3 times larger than you've ever seen it from Earth. Mercury is the smallest planet since Pluto's reclassification in 2006. Its diameter measures 4,880 kilometers, just slightly larger than Earth's moon. But Mercury is much denser, with an enormous iron core comprising 75% of its radius. This gives Mercury stronger surface gravity than the moon, 3 times stronger in fact, though still only 38% of Earth's pull. The planet orbits just 58 million kilometers from the Sun on average, though its eccentric orbit brings it as close as 46 million kilometers. This proximity means solar radiation here is 6.7 times more intense than Earth receives. Currently, the surface temperature around you measures approximately 350 degrees Celsius. The sun you're watching has been descending for what would feel like Earth days, if you measured time that way. On Mercury, sunset is not a brief event. The planet rotates very slowly, completing one rotation relative to the stars in 58.646 Earth days. Meanwhile, Mercury orbits the Sun rapidly, fastest of any planet, completing each orbit in 87.97 Earth days. The combination of slow rotation and rapid orbit creates something remarkable. From sunrise to the next sunrise, one complete solar day on Mercury equals exactly 176 Earth days. That's 2 complete Mercury years for one Mercury day. Daytime lasts 88 Earth days. Nighttime lasts another 88 Earth days. This strange day length results from what astronomers call a 3-to-2 spin-orbit resonance. Mercury rotates exactly 3 times for every 2 orbits around the Sun. Most tidally locked bodies show 1-to-1 resonance, always showing the same face to their primary body, like Earth's moon. But Mercury's resonance is different, more complex, creating its bizarre solar day duration. The resonance formed over billions of years as the Sun's gravity gradually influenced Mercury's rotation through tidal forces. Mercury's slightly non-spherical shape allowed the Sun to grip it gravitationally, slowing its rotation until it settled into this stable 3-to-2 pattern. The planet will continue this dance for millions of years ahead, rotating 3 times per 2 orbits, indifferent to observers. For thousands of years, humans observed Mercury as a swift, wandering star, appearing alternately in evening and morning skies. Ancient Greeks initially believed they were seeing 2 different objects. They called the morning appearance Apollo, the evening appearance Hermes, after the messenger god who moved swiftly between realms. Pythagoras, or possibly earlier astronomers, first recognized both apparitions as a single planet. The name Mercury comes from the Roman equivalent of Hermes, chosen because the planet moves quickly across the sky, completing its orbit faster than any other planet. What ancient observers couldn't know was that Mercury's day is actually very long. The swift orbit masks the patient rotation beneath. Speed and slowness coexisting in the same world. In 1889, Italian astronomer Giovanni Schiaparelli observed Mercury through his telescope, sketching albedo features, light and dark patches on the surface. Based on his observations, he concluded Mercury was tidally locked to the Sun, always showing the same face sunward, like the Moon faces Earth. This seemed logical and went largely unquestioned for 76 years. Astronomers accepted that Mercury had one permanent day side baking eternally, one permanent night side frozen forever. But in 1965, radio astronomers Gordon Pettengill and Rolf Dice used the Arecibo radio telescope to bounce radar signals off Mercury. The returning echoes revealed Doppler shifts, indicating Mercury rotates much faster than synchronous locking would allow. The planet spins once every 59 days, not once every 88. Schiaparelli's accepted truth collapsed overnight. Giuseppe Colombo, an Italian mathematician and engineer, analyzed the radar data and calculated the precise relationship. He discovered the 3-to-2 resonance. Colombo later reflected, "The radar data seemed to contradict visual observations until I calculated the 3-to-2 ratio. Suddenly, everything fit. Mercury shows us the same face every 2 orbits, not every orbit. the planet dances with the sun in precise rhythm. This breakthrough explained why Schiaparelli saw the same features at alternating elongations. Mercury does show patterns, but across a 2-orbit cycle, not one. Mathematics revealed what telescopes couldn't clearly see through Earth's atmospheric distortion and Mercury's solar proximity. Sometimes you need to listen with radio ears instead of looking with optical eyes, as Pettengill noted. Different methods reveal different truths. Around you, the Mercury landscape tells stories of ancient violence. The surface you're standing on is part of the most heavily cratered terrain in the inner solar system. Impacts have scarred this world for over 4 billion years, with no atmosphere or water to erode the evidence. Every crater remains pristine, sharp-rimmed, perfectly preserved from the moment of impact. In the distance, beyond the horizon, lies Caloris Basin, the largest confirmed impact crater on Mercury. It measures 1,550 kilometers in diameter, formed approximately 3.9 billion years ago during the late heavy bombardment. The asteroid struck with such violence it created concentric mountain rings and disrupted terrain on the opposite side of the planet. The shock waves traveled through Mercury's interior and focused at the antipodal point, creating chaotic, jumbled terrain where they converged. One impact, planetary scale consequences. Crossing the landscape closer to your position, massive cliff faces rise from the cratered plains. These are lobate scarps, unique features found across Mercury. Some stretch up to 3 kilometers high and 500 kilometers long, enormous wrinkles in the planetary crust. They formed as Mercury's interior cooled and contracted over billions of years. The iron core solidified gradually, shrinking in volume, causing the entire planet to compress. Mercury's radius decreased by approximately 7 kilometers as the crust buckled and folded to accommodate the shrinking interior. These scarps are planetary wrinkles, biography written in geology. As planetary geologist Robert Strom observed when Mariner 10 returned the first close-up images in 1974, we weren't just seeing surface, we were seeing planetary biography written in wrinkles. The cliffs record Mercury cooling, contracting, aging before your eyes. Notice the sun's position carefully. If you marked its location against a distant crater rim, then checked hours later, you would see it has moved. The descent is imperceptible moment to moment, but undeniable over time. The sun crawls across Mercury's sky at roughly 0.1 degrees per hour. On Earth, the sun appears to move 15 degrees per hour due to our 24-hour rotation. Mercury's rotation is so much slower that sunset, from the sun touching the horizon to complete darkness, can take what humans would experience as multiple sleep-wake cycles. Patience is required here. Patience measured not in minutes or hours, but in Earth days of gradual celestial motion. You're watching the universe at a fundamentally different pace than human experience typically allows. Slower, deeper, more patient. Mercury's orbit is the most eccentric of any planet, with an eccentricity of 0.2056. This means the distance from Sun varies dramatically throughout each orbit. At perihelion, closest approach, Mercury reaches 46 million kilometers from the Sun. At aphelion, farthest point, it stretches to 70 million kilometers. That's a 52% variation in distance, which dramatically affects the solar heating intensity and the sun's apparent size in the sky. At perihelion, surface temperatures can reach 430 degrees Celsius, hot enough to melt lead and zinc. At aphelion, maximum temperatures only reach 330 degrees. That 100-degree difference based purely on orbital position demonstrates how powerfully solar heating scales with distance. Twice the distance means 1/4 the intensity, following the inverse square law of radiation. Mercury experiences this variation every 88 Earth days as it completes each elliptical orbit. The eccentric orbit creates another remarkable phenomenon, visible from certain locations on Mercury's surface. At longitudes near 0 degrees and 180 degrees, the hot poles, observers would see the sun perform an impossible dance. As the sun approaches the western horizon during sunset, it would appear to slow, stop, then reverse direction and rise backward briefly before finally setting for real. Or at sunrise, the sun would rise, dip back below the horizon, then rise again permanently. This retrograde sun motion occurs because Mercury's orbital speed temporarily exceeds its rotational surface speed during perihelion passage. The rotation carries you eastward, making the sun appear to move westward toward sunset. But at perihelion, orbiting at 59 kilometers per second, the rapid motion around the sun counteracts and briefly overwhelms the rotational effect. The sun appears to move backward for a short time before rotation reasserts dominance. Nowhere else in the solar system can you see the sun reverse direction. Your current location won't witness retrograde motion today, but the straightforward sunset you're observing is remarkable enough. The temperature has been dropping steadily as afternoon progresses. Without atmosphere to retain heat, thermal radiation escapes directly to space. The regolith has low heat capacity with no water, no organic compounds, just silicate minerals and iron-rich materials that release heat readily. Earlier, surface temperature measured 400 degrees in full noon sunlight. Now, in late afternoon, it has dropped to 350 and continues falling. By the time the sun sets completely, temperature will plunge below zero within hours. After 88 Earth days without sunlight, the surface will stabilize at -180 degrees Celsius. From 430 to -180 represents a 610-degree temperature swing, the greatest temperature variation of any planet. Day and night exist as separate thermal worlds here, barely connected. The first spacecraft to visit Mercury was Mariner 10. Launched in November 1973. It conducted 3 flybys between March 1974 and March 1975, photographing 45% of the surface. Mariner 10 pioneered the gravity assist technique, using a Venus flyby in February 1974 to adjust its trajectory for Mercury encounter. This slingshot maneuver is now standard for outer solar system missions, but Mariner 10 demonstrated its necessity for reaching the innermost planet. The mission revealed Mercury's moon-like cratered terrain, detected an unexpected magnetic field for such a small, slowly rotating planet, and measured the extreme temperature variations. Those first close-up images transformed Mercury from a telescopic blur into a geologically complex world. Planetary scientist Robert Strom recalled, "When those first photographs came back, we saw a world frozen in ancient time. craters upon craters, some 4 billion years old. Mercury's surface preserves solar system history. Getting to Mercury is, paradoxically, harder than reaching the outer solar system, despite Mercury's proximity. You're diving into the sun's gravity well, accelerating as you fall inward. The challenge isn't distance, but velocity management. Earth orbits at 30 kilometers per second, Mercury at 48 kilometers per second. To reach Mercury, you must shed Earth's orbital velocity, allow yourself to fall sunward, then brake precisely to match Mercury's faster orbital speed without plunging into the sun. This requires enormous amounts of propellant, or, more practically, multiple gravity assist flybys. Sean Solomon, principal investigator for the Messenger mission, explained the challenge. Getting to Mercury is harder than reaching the outer solar system. You're diving into the sun's gravity well. The hardest part of exploring Mercury isn't distance, it's proximity to sun. 6 years of careful navigation, planet after planet slowing the spacecraft, just to reach the closest planet. Orbital mechanics creates counterintuitive difficulties. Messenger, the Mercury Surface Space Environment Geochemistry and Ranging mission, launched in August 2004. It required 1 Earth flyby, 2 Venus flybys, and 3 Mercury flybys before finally entering Mercury orbit in March 2011. 6.6 years of travel using 6 planetary gravity assists to gradually shed velocity. Once in orbit, Messenger spent 4 Earth years mapping 100% of Mercury's surface at high resolution, measuring composition, studying the magnetic field, and making revolutionary discoveries. The mission confirmed water ice in permanently shadowed polar craters, discovered that Mercury's enormous iron core is partially liquid despite the planet's small size and rapid cooling, documented strange bright hollows formed by volatile sublimation, and measured the planet's gravitational field, revealing internal structure. Messenger transformed our understanding. Mercury shifted from the least known terrestrial planet to comprehensively mapped and characterized. 4,000 orbits revealed a world of extremes and paradoxes. One of Messenger's most surprising discoveries was water ice on the hottest planet. At Mercury's poles, crater geometry creates permanently shadowed regions where sunlight never reaches. The planet's axis has almost no tilt, just 2.1 degrees, so polar crater floors remain in eternal darkness. Radar observations from Earth detected bright deposits in these craters, and Messenger's neutron spectrometer confirmed they contain water ice, likely mixed with darker organic compounds. Ice layers extend up to 3 meters thick in some locations. While the dayside roasts at 430 degrees, these cold traps maintain temperatures below -170 degrees continuously. Planetary scientist David Lawrence noted, "We found water ice on the hottest planet. Mercury simultaneously hosts the solar system's greatest heat and preserved ancient ice. Extremes coexist." The innermost planet harbors ice potentially billions of years old, delivered by comet impacts and preserved in shadows. Heat and cold separated by mere kilometers. Beneath your feet, Mercury's interior structure is unique among planets. The metallic iron core comprises approximately 75% of the planet's radius. For comparison, Earth's core is 55% of our radius. This enormous core-to-size ratio suggests violent impact early in solar system history. The prevailing theory proposes a Mercury-sized body once had a thicker silicate mantle, but a massive collision stripped away much of the lighter rock, leaving the dense iron core as the dominant component. Despite Mercury's small size and old age, the outer core remains liquid. Messenger gravity measurements detected subtle changes in Mercury's rotation rate over time, possible only if liquid sloshes within. This liquid iron generates Mercury's magnetic field through dynamo action. The field is weak, just 1% of Earth's strength, but it's measurable and active. Only rocky planet besides Earth with a working magnetic dynamo. Tiny Mercury refuses to be geologically dead. The sun continues its patient descent. You can see it's lower now than when you first began observing. The white brilliance remains undiminished. There's no atmospheric dimming, no reddening as on Earth where sunset light filters through thick atmosphere turning orange and crimson. Mercury's sun stays white hot until the moment it drops below the horizon. Then, instantly, darkness. No twilight, no gradual dimming. On Earth, twilight can last 30 to 60 minutes as sunlight scatters through atmosphere, illuminating the sky even after the sun has set. Civil twilight, nautical twilight, astronomical twilight, each phase defined by how far below the horizon the sun has dropped. Mercury has none of this. The transition from day to night is binary. Sunlight or darkness. Nothing between. When the last sliver of solar disk drops from view, stars appear at full brightness immediately. The longest sunset ends in an instant. Surface temperature has dropped below 200 degrees now. Heat radiates away into space at a rate determined purely by the temperature difference between surface and the cosmic background. The rocks around you still glow with infrared radiation, invisible to human eyes, but intense nonetheless. The side of each boulder facing the sun remains scorching. The shadowed side has already dropped below freezing. Temperature contrasts exist across centimeters, not kilometers. One small rock can span hundreds of degrees of temperature difference, depending on which facet catches sunlight and which faces darkness. Without air to conduct heat or convect warmth, each surface exists in its own isolated thermal state. Touch the sunlit side of a rock and you'd combust. Touch the shadowed side and you'd freeze. Both extremes available simultaneously. Mercury offers no moderation, no middle ground, just the extremes physics allows. Scattered across the landscape around you are strange features unique to Mercury, called hollows. These are irregular bright depressions ranging from tens of meters to several kilometers across. They appear as fresh white or cream-colored material, contrasting sharply with the ancient, darkened regolith surrounding them. Hollows form through a process called sublimation, where volatile compounds buried in Mercury's crust are exposed by meteorite impacts and then vaporize directly from solid to gas under the intense solar heating. The volatiles escape, leaving behind bright deposits of less volatile minerals. Approximately 10% of Mercury's surface shows these features. They're geologically young, some possibly still forming today, proving Mercury remains an active world despite its ancient appearance. Messenger images revealed hollows in sharp detail, sparkling bright against dark crater floors. Another Mercury paradox: ancient surface, recent features. Stasis and change coexisting. The planet continually surprises those who study it closely. Notice how the stars are visible even now, with the sun still above the horizon. The black sky shows thousands of points of light scattered across the celestial sphere. You can see constellations exactly as ancient astronomers knew them from Earth. Orion the Hunter, Taurus the Bull, the zodiac patterns, all visible, though from Mercury's position 50 million kilometers closer to the Sun, slight parallax shifts their positions minutely. The familiar patterns remain comfortingly recognizable. As the Sun descends further, stars near the western horizon become easier to distinguish against solar glare. Soon the entire celestial sphere will blaze with unwavering points of light. On Earth, stars twinkle because atmospheric turbulence bends their light randomly. Here, with no atmosphere, stars shine steady and still. Perfect points of light in perfect darkness. The universe presents itself without interference or distortion, pure and clear. Even now, in December 2025, a spacecraft is approaching Mercury. Bepi Colombo, a joint mission between the European Space Agency and Japan's JAXA, launched in October 2018. The mission requires 9 planetary flybys, 1 Earth flyby, 2 Venus flybys, and 6 Mercury flybys to gradually break into Mercury orbit. Arrival is expected in December 2025, after a 7-year interplanetary journey. Bepi Colombo will deploy 2 separate orbiters. ESA's Mercury Planetary Orbiter will study the surface and interior structure. JAXA's Mercury Magnetospheric Orbiter, called MEO, will study the magnetic field and its interaction with solar wind. Together, they will provide unprecedented detail about Mercury's composition, core dynamics, exosphere, magnetic field generation, and hollow formation mechanisms. Project scientist Johannes Benkoff notes, Mercury remains the least explored terrestrial planet. Every mystery solved reveals 3 new questions. The innermost planet guards its secrets zealously. New discoveries await. The sun's lower edge approaches the horizon now. The moment you've been patiently waiting for, through Earth days of gradual descent, compressed into this peaceful observation. The brilliant white disk touches the distant crater-marked horizon line. Sunset. True sunset. The beginning of the end of Mercury's 88 Earth Day daytime period commences now. Surface temperature continues dropping. 150 degrees. 100 degrees. The infrared glow fades from the rocks surrounding you. Heat escapes to space with nothing to hold it back. No atmosphere to trap warmth. No oceans to store thermal energy. Just direct radiation into the cosmic void. The cooling accelerates as the sun descends further. Mercury surrenders its heat as readily as it absorbed it. Extremes in both directions. Nothing held, nothing retained. Pure physical response to pure physical forcing. Half the solar disk has dropped below the horizon. The black sky above is now fully populated with stars burning steadily. The Milky Way band arcs overhead, that familiar river of light visible from Earth's dark sights. But here, sharper, clearer, every individual star distinct. Billions of stars in the galactic disk spread across the sky. You can see details invisible from Earth's surface, subtle nebulae, distant clusters, the true richness of the galaxy. And all this visible while the sun still partially illuminates the landscape. Day and night existing simultaneously. Mercury's lack of atmosphere creates this impossible juxtaposition. Sunlight and starlight sharing the same moment. As the sun continues sinking, the balance shifts. Darkness gains ground. The long night prepares to assert itself. Only a sliver of sun remains visible now. A brilliant white crescent clinging to the horizon. Surface temperature has plunged through 50 degrees Celsius. Below zero now. Freezing. The transition from blazing heat to frigid cold happens over mere hours as thermal radiation carries energy away unimpeded. This is the fastest large-scale cooling in the solar system. The rocks that were too hot to approach hours ago are now cold to touch. Temperature continues falling. -20 degrees, -50. And the sun, that massive presence dominating the sky for 88 Earth days, prepares to vanish completely. The moment arrives. The last point of white light. The final glimmer. And then, darkness. The sun has set. Instant transition from partial sunlight to complete darkness. No lingering glow. No twilight colors painting the horizon. Just stars, sudden and brilliant, filling the entire sky. The darkness is absolute except for starlight. This is the beginning of Mercury's night. 88 Earth days of darkness stretch ahead. 88 days before the sun rises again at this location. 3 Earth months of continuous night. The longest night any terrestrial planet offers. Perfect darkness for rest. Temperature continues its descent toward the eventual minimum of -180 degrees. Heat memory fades. Cold establishes dominion. The long night settles over Mercury's ancient surface. Silence. Stillness. Rest. Above you, the stars remain perfectly steady. No twinkling. No wavering. Each point of light unwavering in the vacuum. Constellations wheel overhead as Mercury continues rotating. The 3-to-2 resonance dance continues. Mercury rotates 3 times per 2 orbits. Patient, precise, indifferent to observation. The mathematical elegance that Giuseppe Colombo discovered persists whether witnessed or not. Orbital mechanics continue. The planet follows physical law. And you rest here in the darkness between one sunset and the next sunrise. Safe, still, peaceful. Surface temperature, -70 degrees and falling. The regolith releases its final stored heat. Thermal radiation streaming upward into space. In a few more hours, temperature will stabilize. Equilibrium between minimal internal heat and radiation to space. -180 degrees. Colder than Earth's coldest polar winter. Colder than Mars. But you are protected, comfortable, observing safely. The cold cannot reach you. Only the peace of this environment, the stillness, the perfect darkness. Somewhere far above in the darkness, Earth hangs in Mercury's sky. A blue dot, a morning star or evening star, depending on orbital positions. The world you came from, visible from here as Mercury is visible from there, connected across 50 million kilometers of space. But here, on Mercury's surface, in the long night, all that matters is rest. The 88-day darkness supports it. The perfect stillness encourages it. Your breath slow and easy. Your body completely relaxed. Your mind drifting. The longest night in the inner solar system holds space for your rest. Sleep comes naturally here. Mercury's magnetic field, weak but persistent, shields this world slightly from solar wind. The field lines arc from pole to pole, generated deep in the liquid iron core. Invisible protection. And you rest under that protection, under the star field, under the cosmic darkness. 88 days of night. But you need only this one Earth night, this one period of rest. Mercury's patience teaches you patience. Mercury's stillness teaches stillness. Mercury's darkness teaches rest. Sleep now. The long night continues. You are safe within it. The scarps, those planetary wrinkles, remain in darkness around you. 3 kilometers of cliff face, invisible now, known only by starlight. The craters retain their shapes, ancient and patient, unchanging. Mercury's geology frozen in time 4 billion years ago. Nothing erodes here. Nothing weathers. Only impacts. Only slow cooling. Only time. And in this frozen, ancient landscape, you find perfect stillness, perfect quiet, perfect rest. Imagine the hollows in darkness. Those bright deposits invisible now without sunlight, waiting for the next sunrise 88 days hence. Volatiles locked in the surface, preserved in cold, until the sun returns to vaporize them again. Cycles within cycles. The 3-to-2 dance continues. Rotation, orbit, resonance. Mathematical beauty in celestial mechanics. Colombo's elegant ratio playing out in darkness. 3 rotations per 2 orbits. Forever. Or until tidal forces change again in deep time. For now, stable, predictable, peaceful. The colorous basin rests in darkness, far beyond your view. 1,550 kilometers of ancient impact structure, silent under stars. The shock that created it happened 3.9 billion years ago, long before any observer, long before awareness. And the basin remains, recording that ancient violence, now peacefully dark, still, quiet. All of Mercury's history, all its extremes, all its paradoxes, rest now in the long night. And so do you. Rest deeply. The darkness holds you. The stillness surrounds you. Messenger ended its mission in April 2015. Nancy Chabot, mission scientist, reflected, "We deliberately crashed Messenger into Mercury at mission end. After 4,000 orbits, the spacecraft became part of the world it studied. Poetic ending. A new crater, perhaps 16 meters across, added to billions of existing craters. Part of Mercury now. And Bepi Colombo approaches. New observations arriving soon. New understanding. But for now, in this moment, in this long night, only rest matters. Only peace. Only sleep." Your breathing slow and rhythmic. 4-count inhale. Hold. 6-count exhale. Each breath deeper into relaxation. Each breath releasing more tension. The stars above remain constant. The darkness remains complete. The cold deepens gradually toward negative 180 degrees, but you are warm, comfortable, safe. Mercury's extremes cannot touch you. Only the peace of this place reaches you. Rest now. Hari Nair, planetary scientist, observed, "Mercury is a world of absolutes. Every extreme teaches us about planetary processes operating at their limits. Hottest days, coldest nights, biggest core, longest day relative to year. And tonight, you experience the extreme of darkness. 88 Earth days, perfect for deep rest. though you need only one night, one period of sleep. Mercury's night lasts far longer than you require. More than enough darkness, more than enough stillness, more than enough peace. The sun will not rise here for 88 Earth days. No dawn approaching in hours, no twilight arriving, just darkness. Stars, cold. Time passing at Mercury's patient pace. If sleep requires darkness, Mercury offers ultimate darkness. If rest requires stillness, Mercury provides stillness measured in planetary rotation periods. Complete absence of change, complete absence of disturbance, perfect environment for sleep. And you settle into it, gratefully, peacefully. Temperature stabilizing now. -180 degrees Celsius. Equilibrium reached. The surface will maintain this temperature for the next 88 days. Stable. Unchanging. Heat gone. Cold established. Balance achieved. And in this stable environment, you find your own balance, your own equilibrium. Body and mind in rest. Breathing slow. Heartbeat calm. Thoughts drifting. The 3-2 dance. Invisible in darkness, but continuing. Mercury rotates. 58.646 Earth days per rotation. Mercury orbits. 87.97 Earth days per orbit. 3 rotations. 2 orbits. Perfect resonance. The mathematics of celestial mechanics playing out, whether observed or not. The universe following its laws. And you, resting here, part of that universe, following your own natural law. The need for sleep. The pull toward rest. Mercury doesn't rush. Neither should you. The planet teaches patience through its slow rotation, teaches acceptance through its extremes, teaches rest through its long night. 88 days of darkness, more than sufficient, more than generous. You need only a fraction. 1 Earth night. This night. And the darkness supports you. The stillness holds you. The peace surrounds you. Stars overhead. Unwavering points of light. The galaxy, visible in full glory. Billions of stars. Ancient light. The same stars visible from Earth, but clearer here. Sharper. Steadier. The universe presenting itself without atmospheric interference. Pure. Clear. And you observe from perfect stillness. perfect darkness, perfect peace. The long night continues. 88 Earth days ahead. But your night, your rest, requires only hours, not days, not weeks. Mercury's patience exceeds your need. The darkness lasts longer than your sleep. Perfect. No rush, no urgency, no dawn approaching too soon. Only time, only darkness, only rest. Your breath, barely audible now. So slow, so gentle. Each inhale bringing peace. Each exhale releasing everything else. Nothing to hold, nothing to grasp. Only breath, only moment. The stars keep watch. Mercury endures. You rest. Floating in darkness, supported by stillness, held by peace. The innermost planet offers deepest rest. Paradox. Beauty. "88 days of night. You need only this one. Stars above, darkness around, peace within. Mercury's sunset complete. The long night begun. Temperature stable. Darkness complete. Rest perfect. Three rotations per 2 orbits. The dance continues. Nothing changes for 88 days. Perfect stillness. dark, peaceful. The stars remain constant companions. Your breath, slow, gentle. Mercury rests. You rest. All rests. Darkness lasts. Sleep comes. The longest night. Perfect for sleep. Nothing disturbs this darkness. Nothing interrupts. "88 days. Ultimate rest." Stars, silence, sleep. The night holds you. Rest now. Mercury's patience. Your peace. deepest darkness, deepest rest. Sleep. Mercury rests. You rest. Iron core cooling. Surface cooling. "88 days of darkness." Embrace it. No sun to wake you, only stars. The longest night, the deepest sleep. Temperature falling. Peace rising. -180 Celsius. Perfect stillness. Ice in shadowed craters, preserved forever. You preserved in sleep, held by night. messenger mapped this world. You rest upon it. Bepi Colombo approaches. Discovery continues. But tonight, only rest, only peace. Sun will return 88 days hence. Until then, darkness. Until then, sleep. The retrograde sunset complete. Strange beauty witnessed. Now only night. Now only rest. smallest planet, longest night. Closest to sun, deepest in shadow. Paradox of Mercury. Comfort of darkness. Stars wheeling slowly, time passing gently. No urgency here, no rush. "88 days to simply be, to simply rest." Mercury's gift. Time for sleep. scorched world cooling. You cooling into rest. Heartbeat slowing, breathing deepening. Mercury night surrounding, sleep claiming. Ancient cratered surface, ancient peace. Calorous basin in darkness, you in darkness. Both resting, both still. The iron planet sleeps. You sleep with it. magnetic field whispering, protecting. One 1% of Earth's strength. Enough. Enough protection. Enough peace. Rest now on Mercury. Rest deep. Sunset complete. Night begun. Days ahead, all for rest.